All right, so good morning, guys. Today we're gonna go ahead and uh, shift gears a little bit. For the last 2 weeks, you guys have been focusing pretty heavy on front end, and today we're gonna shift over to SQL schema design. So I am under the impression that you guys kind of already started Postgres, so it shouldn't be too much of a change right off the bat. Um, should be an easy transition, but we're gonna build off from what you guys already started early on in the cohort. Can you guys see my screen?
Yep.
Awesome. All right. So schema design. So what is schema design, right? So the best way to put it in layman terms would be a blueprint, right? A blueprint for your tables and the relationships that they share, as well as all the fields and constraints that go into it. All right. So schema design is crucial. It's one of the biggest parts of when you first start your project. If you don't put enough time into your schema design, you come to have more of a headache later on trying to fix your database, right? And when it comes to schema design, there are some good practices and some bad practices that we take into consideration. All right, so for the good practices, starting off, we have the normalization. So I'm assuming you guys have already some form of an introduction to normalization. So we're going to cover them briefly, but we're not going to go too deep into the weeds of it. All right, so when it comes to normalization, it's always important that we follow the three forms of normalization, ensuring that don't have within the same columns, right? Or having columns with multiple data that it really shouldn't have, right? It take into consideration, like if you had employees with employee IDs and phone numbers, it's probably not the best idea to load up one cell with three different phone numbers, right? Thinking back to like the military, a lot of times people have work phones as well as their own personal cell phones. And if we were to be keeping track of their contact information, maybe not the best idea to put all that within one cell. Uh, Other things that go into the first number form being, having a table without primary keys or repeating groups, right? Second number form being how the non-key columns relate to the primary key. So trying to avoid those partial dependencies. And then your third number form being getting rid of the transitive dependencies, essentially a column that is dependent of a non-primary key. Um, you know, of a non-primary key that is dependent of a primary key column. So every non-key attribute in the table should depend on its own key, the whole key, and nothing but that key, right? Using primary keys, another good practice, right? So each table should have their own primary key. Primary keys are usually unique, right? They identity for that record, and that's what we use to kind of reference that record. One of the things that you want to avoid is using columns that might change frequently as primary keys. So if you were to have a table with, let's say, teachers and the classes that they teach, might not be a good idea to have the primary key to be the name of the instructor, because as you know, instructors might change or the name of that class might change as well. Foreign keys for relationships. So using foreign keys to establish the relationship between your tables. That's always a good practice as well in ensuring that you uh, adhere to those. So another thing to also keep in mind when coming to your foreign keys is the cascading effects. So when you start creating your relationships, these relationships essentially are going to become dependent of each other. And when you try to drop tables and remove stuff, you might encounter issues where uh, there's like cascading effects where like, oh, you can't drop this teacher table because it's dependent on this class table, right? Because they share that relationship. Another good practice being your data types and your constraints. All right, so choosing the appropriate data types. If we were to use an example, think of like, let's say a game, you're creating the game inventory for your character, right? If you're setting up the database and you wanted to create an inventory for this character, you probably wouldn't want to have the items in that inventory to just be a text field of, this long string of being like, we can say like one amulet, 10 gold coins. It would become very awkward when trying to query, So keeping in mind the data types you use, as well as the constraints. All right. So if something shouldn't be no, probably not using no, making things that should be unique, helping maintaining that data accuracy. Another thing is the storage and performance that goes into it. As you'll find out later on, that different types of data types they use do have a difference in storage. Although they might be minuscule at first, you might have like your big ints and small ints, and it might be like 2 bytes or 4 bytes of a difference. It always adds up once you start looking at thousands of data. Indexes. Indexes is another good practice. We won't cover indexes today, but essentially, a quick rundown of indexes. You use your indexes to speed up the query performance. So if you know you have some form of data that you're finding yourself that you're going to be querying a lot pretty often, it's always good practice to use an index to increase the performance of querying that data. Now, indexes can also be a double-edged sword. When it comes to your indexes, you might not want to overuse them. A nice quote I like to think about when thinking about indexes is going back to The Incredibles, right? So if you think about like, if everybody's super, nobody's super. So what's the point of using too many indexes if it's trying to speed up multiple things? Eventually, it will just end up slowing down and kind of, not doing what it should be doing. So using too many indexes can slow down your operations. Consistent naming conventions. And this kind of goes back to everything else that you guys have done so far in the cohort. You want to make sure that you have consistent naming conventions to ensure that, besides the uniformity, but to not make it difficult when querying tables. It would be very difficult if you have every single table a certain type of format, and then you decide to change the formatting for one table and essentially making it very difficult to even find it later on. Avoiding overly complex or ambiguous names. So far with our like formatting for like naming variables, we try to sometimes, what's the word? We try code fast, so we cut shortcuts. We make shortcuts into our naming conventions. Instead of typing out list, we type in LST, right? So avoiding names that you're not exactly sure what it could be. Documentation, same thing with everything else that we've learned. Having good documentation can go a long way. It's not going to be just you working on different projects. Once you guys start working in teams, you're going to have other developers that's going to be looking at your code, right? So it's going to be very difficult if you do not add documentation. And for your time here in the cohort, it'll be even difficult for you guys when you later on try to use your code for your interviews or whatever work project you create. Don't be like me showing up to an interview, demonstrating a project I had not touched in months, and then not using documentation, trying to figure out what my function is doing, right? So documentation can go a long way, not just for yourself, but everybody else in your team, as well as performing maintenance on your code. Bad practices. This is kind of a given. Pretty much taking everything else that we talked about, the good practices, just the opposite, right? So denormalizing without reason. So it can lead to the inconsistencies in your code. It can be challenging to conduct maintenance, ignoring indexing, right? So if you have indexes in your code, use them. Right? What's the point of having it if you're just going to ignore them anyways, right? As well as neglecting to even create them in the first place, especially if you know that you're going to be querying certain data pretty often. Unrestricted null values, right? So allowing excessive null values can make it challenging to enforce data integrity. So if something doesn't have to be null, there's no reason to make it null. Later within the curriculum, we'll talk about the times to make something null or when and where you want to use it. But something to keep in mind, ignoring the null values. Ignoring relationships. So when it comes to your relationships, right? So leaving out table relationships can increase data redundancy, and it can increase risk inconsistency. Naming conventions, right? So inconsistent naming conventions. Once again, it can make your database hard to understand, or more importantly, fine. So stick to one naming style to keep things clear for you and your team. Skipping documentation. If no one knows design logic, future changes or fixes can become very difficult. All right, so documenting your schema and decision helps everyone stay on the same page. Ignoring security, right? So when it comes to security, there's some things to take in mind. Um, so ensuring proper permissions to protect the data from unauthorized access. You don't want to give access to everyone to do every single thing within your database. It might not be a good idea to allow your new intern to drop the entire data protection, right? So keeping things in mind like that, like who has permissions to do what within your database, right? So role-based access control, ensuring the specific types of access, and granting minimal privileges to avoid any kind of issues. Scalability, it wasn't within the good practices, but for the bad practice, ignoring the fact that your project might increase later on, right? So when you first start off, you have an idea of what your project might do, but if your application becomes bigger, you might have to have uh, to add a lot more data than you expected. And the way to not fall into this category is honestly by following all the good practices. If you stick to the normalization, good practices, then you won't find yourself having issues with the scalability of your project as well as proper naming conventions, right? Using indexes, the unrestricted no values, all that affects your scalability. So to prevent yourself from falling into this category, following the good practices will essentially counter the scalability issue that you'll have. So up to this point, do you guys have any questions about the good practices and bad practices of your schema design?
As far as
Oh,
indexing, what specifically is that referencing to? Just like an index and an array?
no, indexing, I know, right? So you think it's pretty similar because of the word indexing. So essentially, you are creating somewhat of what's the best way of explaining it? Um, it's almost like commenting into a piece of code saying, "Hey, this is very important. I'm gonna use this very often, so I want you to focus all your processing power on grabbing this data faster." That's kind of how indexing works. I know they use the same type of naming convention like indexing a list, then indexing here. It's not necessarily the same thing, but at the same time, thinking about index, why do they use the same word index? Well, the index allows us to know where something is in the list, therefore increasing our access to it, right? If we know the index, we know where to find it faster, right? So whenever you are trying to access item in the list, when you try to use like the in operator on the list, the way that happens under the hood is that it's essentially creating a for loop, right? But if you use the index, that access is immediate. It doesn't have to go through the entire list to find that specific object. So thinking with that type of functionality within this code for your schema, indexing pretty much lets your computer know, hey, like I know this specific item right here is being used often, right? So I'm going to focus all my processing power here, therefore increasing the acceptability to it. Does that make sense?
Kind of. I mean, it just sounds like a key, but not a primary key. So I'm assuming this is an SQL only function that we're talking about,
As far as
or
I'm tracking,
functionality.
yes, it's by increasing the processing power on that thing, right? So think of like let's say gaming laptop or gaming computers, right? A lot of gaming laptops, when they run games, they focus all their processing power on just running that game to increase the process speed and to run your game a lot smoother. Uh, Postgres essentially going to be doing the same thing. It's going to focus all its processing power on just querying that specific data that has that index, right? James.
I was curious when you're building all this, like these tables and schemas, like should you only be doing it on the data you have, or should you be imagining like future data you might be getting later? But I assume there's a lot of nulls you would get if you're just like imagining future data inputs that you would use later. Is that making sense?
Yeah, so that's a good question, right? So when it comes to actually thinking about how you're going to design your schema, so you find yourself in two different scenarios, right? You might be contracted by somebody. Let's say if you're a freelancer and you're trying to work on somebody's website for a business. They might already have data. They might already have records that they're probably logging within like an Excel spreadsheet, where they have like their customers, their sales, whatever it may be. So sometimes you might already have the data, accessible to you, where you can use that to kind of create the schema for the application. Or in your case, for you guys who you're going to be creating your applications, you will have an idea of what you want to build. So when you start thinking like, let's say that you guys want to create a work app, like think like a work app that gives you workouts, right? If you know that you want to create a website that provides workouts for you, then you use that logic. Will think to yourself, what kind of info do I want to have in my database? I should probably have the type of workouts, time durations, muscle groups. So you start taking all these different factors into it, and you think to yourself, what do I need to provide for the user, right? What kind of data should I be saving so I can use that for my front end, so I can give it to my user. So depending on what your end goal is, will dictate what you're going to create for your schema. And it's kind of just prioritizing what you actually really need. Does that make sense? All right, so sometimes you will have
Yes.
data, sometimes you won't.
Right. Thank you.
No problem. Anybody else, guys? Okay, I do apologize if I'm not looking directly to the camera. My webcam is on my laptop, so it might look a little weird if I'm looking to the side. All right, so moving forward. So we discussed good practices and bad practices. Now let's get into understanding the entity fields in PostgreSQL, right? So the first one we're going to cover is going to be your serial and primary key fields. So we do have multiple different field types. The first one being your key fields, and that's usually what, as discussed before in the good practice, what identifies that table. The serial and primary keys are not exactly the same, right? You can create a primary key and assign it to a specific uh, field and not be a number. But what serial does for you is it allows you to increment that number as you add more data into your table, right? So as mentioned before in the good practices, you might not want to set your primary key into the name of somebody, right? It's always good to use a serial primary key where it becomes essentially like an ID number. And if you add stuff into your database, it's automatically incrementing it for you, right? So it's ideal for primary keys to ensure each record has a unique identifier. That's going to be the first field type you will talk about, and you'll see that also on display with our example of how that works, right? Essentially, we can actually start drawing some stuff here for you guys so you can kind of see an example. So if you were to have your table, you have the fields on top. And I do apologize for my TL draw skills. I'm not as proficient as it with Francisco. I don't really use this, so this is brand new to me, right? So if you were to have like your employees, right? A serial primary key could be something like an ID. And by making it a serial primary key, what happens is when you add an employee into your field, let's say this is going to be Bob. The first time you add your first employee, that serial primary key will allow you to automatically create that first entry, which will be set to 1. And you continue with the addition of different data into your table, serial primary key will recognize that and automatically increment that for you. You can have something like 1 Bob, 2 Alice, and as you add more, the serial primary key will automatically increment, right? And we use these keys to be able to relate to each other. And you'll see that in play as we move forward. Varchar and text field. So these are kind of they're different and they have their uses, right? So varchar and text fields are one of the ones that you're going to be seeing pretty often when creating different forms of text. And there are other text fields that we can use. We have char, varchar, and text. Varchar and text being the most common one. Varchar is usually used for a specific n amount of characters, right? I believe varchar is 255. So if you have some form of text that's not too long, but it might be like, let's say, a name or the name of a school, varchar, you will use varchar for that. But if you were to have something like a description of, let's say, a Pokemon, right? You want to give the description of the Pokemon or where it comes from, you might want to use text fields because that gives you the ability to add a lot more text than something like varchar would. Varchar is for short strings with a defined length, right? But you want to use, we want to avoid using varchar for very long text. That's when text fields comes into play. So when to use one, the other is going to depend on what your data is actually going to be. Now, I did mention there is varchar and there is also char, and there's some differences from both of them. Char is also another short character type one. The difference between varchar and char is the amount of space they take, right? So with varchar, when you set the limit of how big you want varchar to be, and we can give a little description of that. So let's say you go ahead and create name, and you assign it to a type of varchar. You can give it a max length. Let's say we'll give it 20 characters, right? You can do the exact same thing with char. The difference between both of these is how they actually work under the hood, right? Let's say both of these are set to 20, but when I use char, what's going to happen if someone adds, or if you add some type of data type, let's say a name that only has 5 characters long, it's still going to use the rest of the space as if you use 20 characters. And that's not exactly what you want, right? Although the max length is 20, you don't always want to just take up the entire 20 space if you don't need to. Whereas when using varchar, it won't save that space if it's unused. Now might think to yourself, well, Roger, why would I use char then in that case if I have varchar? Well, chart does take up less space, and there are some scenarios where you might want to use it. Let's say when putting in the acronym for a state, right? For Texas, typically we use like 2 characters for the acronym for a state. That might be a good time to use char, right? Because you know that the max length of char will probably be 2. So you know that's going to be a fixed length, and you only need the 2 spaces. It wouldn't make sense to probably use the acronym for state with varchar with 20. I mean, you could, but what's the point if you have char anyways? And I believe the size for char might be slightly smaller than varchar. That's like the biggest difference that comes with it. But although varchar, I feel, is a lot more superior than char. Right. Just know that char will still take up the space if it's unused, while varchar won't. That's the biggest difference between those two. Do I have any questions about char or varchar? Awesome. So next going to be numeric and decimal fields. So these are kind of similar. Their usage type is what really differentiates both of these. So essentially, when it comes to your numeric and decimal types, both of these are fixed decimal points, right? And they both have precision. Now, when to use one over the other depends on the use. So numeric for calculations requiring precision, decimal for financial data. The way that you declare these are going to be as follows. Let's say I have a price for a bag of chips. If I wanted to set the price for that, I could use something like decimal. And I've never seen a bag of chips go over $10, so we can say 4, 2. And what this is saying is I want this decimal field to be 4 characters long, with a decimal point of 2. And the way that would look like, actually would look like something like this. Let's say you're getting the big bag of spicy ruffles, so that would probably look like 04.22 or 4.22, right? We don't have to use that 0, but in case it does get up to 2 numbers, it would allow us to add that extra integer in there. But that decimal point is put to the second part. Now you're wondering, well, Roger, this is, 1 to the right. When it comes to the decimal point, it's talking from right to left, right? So if we had, let's say, a pizza that's $12.99, it would look something like this, where it's 4 integer long with a decimal point either 2. Now, what if we have something a little bit more expensive, like Louis Vuitton boots or something? I don't know. I don't own Louis Vuitton. I'm assuming it's probably somewhere like around like 300, right? So we can say 300.99, right? So the decimal point is from right to left, and the first argument is the actual amount of numbers that are going to go into your decimal value. Still with me? Awesome. Do I have any questions about numeric and decimal fields and how to use them? Numeric is going to be used the same way, right? So how do I declare a numeric value? Well, it'll be like finances. It's going to be numeric. And then it will be 6, 2, whatever you want to set it to, right? Same concept, numeric, decimal. They both use the 2 arguments. Second argument being the position of that decimal point. All right. One thing to keep in mind, in most databases, the decimal is functionally identical to numeric and follows the same rules for precision and scale. All right, so just keep that in mind. There's not really a big difference. It's more like what's the word I'm looking for? Semantic. I don't know. English is my second language, guys. It's more like a semantic mean, right? Of when you're going to use them. All right, next is going to be our date and timestamp fields. So this is something you guys going to see often, and there are different types of dates and times, and we're going to talk over them real briefly, right? So we have the first one is going to be our date field, right? So date, and the format for your date, if I remember correctly, it should be something similar to year dash dash dd. All right, so date is used for something like, your date of birth, right? So whenever you guys add your information to some kind of application, they ask for your date of birth. That's the field that you're adding is usually going to be just a date field, right? You probably won't have a timestamp for that field type if you're trying to take in the date of birth of your users. So that's probably when you would use your date time. Timestamp will store the date and the time of something, all right? And the format for timestamp is as follows. Timestamp will be hour, minute, and then SS, I believe. Right, and then I believe for the date it's essentially the same as date, should be year to year dash month, date. Right, so your timestamp will return to it takes in the date and the time. right? So when actually adding data into your database using the timestamp, you can give it a specific type in this format, or you can use the now method, which essentially what it will do is take the current time that is within your location and it'll save it into your database. And we can see that in action later on once we start talking about adding the data into our database. All right, so now we'll take the current time that it is, or you can just add your own pre-formatted date and time. All right, if you have something specific like the time of birth of your birth certificate, right? So use date for birth dates or events without specific times, right? And then you have timestamp for events with specific times, right? Think about maybe like your Google Calendar that you have, or maybe not Google Calendar. What does everybody else use? Teams, like, you know, you have your Teams calendar and you have like appointments or you have some kind of event coming up. It's probably saving it in the format of a timestamp of when to do it, right? You also have timestamp Z, which is almost the exact same as timestamp. The only difference is it adds your time zone. And I'm not too familiar with time zones, but it would look something very similar to this, where you have the year, time, and then plus the time zone that you are located in, or whatever time zone you give it. And this can be time zone, timestamp Z, right? So timestamp, two ways of adding the timestamp or using timestamp Z, right? Yeah, the date one, you also have time. All right, so if you don't want the time or the date, but you just want the time, you could just use the time as well. And notice that this is pretty much very similar to timestamp, the way the time is formatted. You have date, you have time, you have timestamp that combines both of those, and then you have timestamp Z that combines everything as well as the time zone. So these are your date and time fields. Awesome. And the next one we're going to talk about is going to be your Boolean fields. And that's exactly what it sounds like, right? These are essentially just true and false values. You know, what's an example of using a Boolean field? Well, that might be something like if you're creating a database for users and trying to keep track of whether the user is active or not, right? So you can have like an active status, right? Active, and then you would use the Boolean. I believe it should be Boolean, and then you set it to like true. All right. So I deal with fields with binary states like active or inactive, right? Pretty straightforward for the Boolean field. Up to this point, do I have any questions about the different types of fields that we just discussed? Awesome. I do believe that you guys should have a cheat sheet for these. I believe we go to RDMS, we can go to resources. We have a cheat sheet. I guess we don't have one for, I take that back. We don't have one for the fields. But this is a quick Google if you guys want to look up on W3 schools to check out the different dates and times. All right. So moving forward after understanding the entity fields, right? So relationships between tables. And this might be probably the most confusing part for some people. But the different types of relations that we have between all our tables, right? So essentially, we have three different types. And these types are going to be your many-to-many relationship, your one-to-one relationship, and your one-to-many. So the relationships is how your models are essentially related to each other and how they interact, right? The first one we cover, all the way is second on the list, is going to be one-to-one, mainly because it's probably the easiest one to understand. So let's go ahead and move downwards. We're going to go ahead and create some relationships here. And a good example to use will probably be, oh, this is ugly. Where's my circles? Okay, here we go. Would be like person and their passport, right? Or person and their social security number. So only one person can have one specific passport, right? Or only one person can have one specific social security number. Now, you don't have 2 or 3 social security numbers, and that social security number does not belong to 2 or 3 different people, right? So a one-to-one relationship is typically between 2 different pieces of, or 2 different tables that can only belong to each other. This would be, let's make this a little smaller. All right, so you have your person, and then you have your passport. All right. This would be your one-to-one relationship. Right, so person and passport, passport to person. Only one person can have one passport. What's another example that we could use? Think of I guess passport and social security number is probably the best one I can come up with right now. Right, so stuff that shouldn't be belonging to multiple people, right? Think of maybe like your user, right? You only also have one password, right? When logging into your account, you shouldn't have multiple passwords to that exact same account, and that password should probably not belong to somebody else. I mean, actually, it won't really matter if your email doesn't match, right? But we only have one password. That one password only belongs to us, right? Or like your email when creating an account, right? You only, when you try to use an email that already exists, it'll tell you this account already exists, right? So that email and that to that user will only belong to that user. The user will only belong to that email in this application, right? That's going to be your one-to-one relationship, right? So real life example, employee may only have one unique employee ID card, right? And each ID card is associated with only one employee. That is your one-to-one relationship. Recognition process. Look for scenarios where one instance of an entity is related to at most one instance of another entity, right? One-to-one. All right, the next one we'll talk about is going to be our one-to-many relationship, and our many-to-many will be our last one. So one-to-many, a good example would be if you were at the airport, right, and you have your luggage, right? So this person can have multiple luggages, but more than likely, that luggage only belongs to that one person, right? So a one-to-many relationship is one person being able to have multiple luggages, but those luggages only belonging to one person. Why is it not doing what I want it to do? Go away. What is going on? Let's just pretend it's that. All right, one-to-many relationship, right? One person to all 3 luggages, and these 3 luggages to one person, right? So real life example, in a library database, one author can write multiple books, but each book is written by only one author. This represents a one-to-many relationship. Yes, Juan.
Just to be sure, is this one, for example, one to many being one table to many tables, or one item to many items?
That's a good question. So it would be the tables, right? Or No, the items, right? So we can have that's a good question. Thank you. For example, let's actually kind of try to do that, right? So let's say we have here's our table. All right, and this table is gonna be the the author ID is gonna be author, right? So we probably have a database of different authors and within like this library database, we can have one, two, three. We have different authors. We have Susan, uh, we have Gary. He decided to change his occupation. And then we have Juan, right? We have three different authors here. Within this one table, we have the author ID and the author, right? Now, if I wanted to have multiple books, I would have a book table. Right? I don't know how Francisco does it. He's so good at this. Right? You have your book ID. You have your book. And then what will probably happen here is this book will share some relationship to the authors by manner of a foreign key, right? So what that does is something like this, where we have your books. I hope it's not too small. Right, your book ID, and then you have your different books. We'll call this a Python book. We'll call this a JavaScript book. And then you have HTML book and a CSS book. Well, this book ID or this book table, right, is its own individual table. And then we also have a different table for our authors. Well, how do we link these together? Well, the way that's going to work is to ensure that we have this relationship. What happens is we assign the key, right, to the author, right? Or what's probably going to happen here is we'll probably move this ID here actually, and we're going to move it to, how do we do this? No, actually, that's good. All right, so this book table here will keep track of whatever author it shares a relationship with. Susan decided to make the Python book. Gary really enjoyed JavaScript throughout his time here in Platoon. So he made JavaScript and he also made HTML, and then Juan made CSS. Right? So we see here we have our individual authors here. And these authors have multiple books, specifically Gary. He has JavaScript and HTML, but notice that each individual book itself only has one author, right? The Python book only has Susan as its author. We have Gary, who has both JavaScript and HTML, but both of these books only have one author as well. They don't have two, they don't have three. And then Juan, you have the CSS book. But what differentiates this right here is the fact that Gary has two of them, right? He has JavaScript and HTML. So Gary has a one-to-many relationship with this book, Gary being the one and the many being the books, right? And the books share that many-to-one relationship because there's many books, but they only have one author. Does that make sense?
Yeah, so the relationships then would be, it's not table to table, it'd be items to items in this
Pretty
case.
much.
Or yeah, like Gary, right? And then two items over in the book ID, for example,
Yes.
would be one to many items. Okay. Thank you.
All right. You would want to separate these within their own tables, and then you would link them together via their keys, right? And so it's multiple items. So one Gary item has two book items. All right, that's your one-to-many relationship, right? And we use the exact same scenario here within the README. In the library database, one author can write multiple books, but each book is written by only one author. Now, moving on. Actually, before I move on, anybody else have any other question to the one-to-many relationship, or are we good here? Awesome. All right, so next is gonna be our many-to-many, right? And going back to our example here, we use the one person to one passport as the first example, and then we use the luggages to persons, right? So this is gonna be our one-to-many. Let's go ahead and expand this real quick so we can get a better view. This is our one-to-one. And now let's actually talk about our many-to-many. Well, the example we're going to use here is going to be staying within the exact same context, persons and their flights, right? So we might have multiple flights, right? Think about your connecting flights, right? Flight 1, all right, we have flight 1, flight 2, flight 3, and then flight 4. Right, and then we also have our persons. Let's turn this to, it's 1, 2, 3, and then 4. All right, this person might be on their first flight, right? Let's do this for all of them. What's this? The A. Oh, that's how he does it. All right, this person, each one of these people will have one flight, right? They all have their first flight, but when you think about the airport, sometimes we have connecting flights, right? Let's say this person is flying to Dallas, Texas, and then from Dallas, Texas, they're going to Durham, North Carolina, right? This person is going to Durham, North Carolina from Dallas, Texas as well. So that's why they're in this one, but he's not in flight 1 because this is going from Dallas. But eventually, this same guy has to end up on this flight, right? And what you're going to see is that some of these will end up being assigned to multiple other flights. And it almost looks like a spider web, right? Many people can have many different flights. And simultaneously, many flights can have many different people on board, right? So the difference between your one-to-many and your many-to-one is the fact that it goes both ways, right? If we were to convert this into a many-to-many connection, let's change the scenario. Let's say in this scenario, there's the multiple authors, and you kind of see that sometimes in some books, especially like educational books, like your history, your math books. It'll be a combination of different authors that contribute to the book, right? So what happened is maybe both Juan and Gary both contributed to HTML. So this will have like two different authors, and the book will belong to two different people, right? Same concept with your flights. Many people can have multiple flights at the same time. All these flights can also have different other people in them, right? Now, the way that this works table-wise, it's a little bit different, right? Here, it was pretty self-explanatory where we have two different tables, right? One table for the author, one table for the book, and they're only assigned one author ID, right? Showing that one-to-many relationship. The way that it has it for many-to-many, we're gonna need a third different table, all right? Let's use this example. And then let's remove this. Right? We have our book table, and then, oh no, what happened to the numbers? Author ID. Makes it pretty. 1, 2, 3. Right, we have our author table, and then we have our book table. Well, how do we create that many-to-many relationship? The way this works with the tables is we're gonna need to have some form of a third party, right? We introduce a different table. This table is what's gonna connect your authors to your books. And we'll call this author books. I'm not creative. All right, this will be an author books table. This will be author book IDs. And this will be what would happen here. Oh no. Of course, Gary, doing your own thing. There we go. We have our table. We're gonna have two different IDs. One will be author ID, and the other will be book ID. Right? You have your author ID, and then you have your book ID. And then we'll probably also have will be like its own ID as well. So author book IDs. Or actually, the way we'll probably do this will be we'll have, let's just say IDs, author IDs, and then trying to visualize this in here. Okay. I hate squares. All right, so we have the ID, the author ID, and the book ID, right? And then we have different entries. So let's go ahead and delete this right here. The way that this will share the relationship will be just like this, right? We'll have to share the relationship Susan, right? We said that she created Python, right? So we'll have Susan's ID within this table for author IDs, right? And then we have the ID for the book saved into this table, right? So what this is saying is that I have a author book ID table, right? The relationship is here where author ID and book IDs are put together. And let's actually name this table so it's easier to understand. Author book ID table for now. And this is author book ID. All right, so we know Susan has she has that relationship with Python. Well, now let's actually do the menu-to-menu. We have Gary, right? Gary's ID is here for 2, and he shares a relationship with JavaScript. So we put the book ID for JavaScript. Next, we have Juan, and Juan has the same relationship with that book ID, right? So in short, what happens here, Susan gets added into book ID. What is going on? I'm not good with skill draw. All right, I'll figure out later. Let's draw instead. All right, so Susan, author ID and book ID. Gary, right, he shares a relationship with JavaScript. Juan also shares a relationship with JavaScript, right? And that relationship is established, with this third table, right? Or we can connect the author's IDs and book IDs to each other, right? And we don't have the exact same data all within one field like we had for the for other stuff, right? Because it would be weird to have author ID, author, and then book ID, and then we just add a bunch of IDs within one field, right? As we talked about normalization, we don't want to have different cells with multiple different data, right? So the way that you do that is you separate it by adding that third table that interconnects both of these. And this will make a little bit more sense once we actually start drawing it within our scheme design. Does anybody have any questions so far? Juan, I see your hand raised.
Yeah, just to double check when you just finished saying the author book table, basically that function that table is doing is not only connecting but establishing the connection between that other table and then this table. Is that right?
Yes, this table is what's linking both tables together. Right, you made the connection within this third table. Right. Earlier, as we saw here, it wasn't an issue, right? Because we can just assign it in the author ID into a different column, and they share each other. But if I wanted to add, Juan also to JavaScript, let's say he actually took part in this, then that would make it a little tricky. I would start to have to add the IDs of other authors in here, right? And we don't want to be, what's that noise? I heard a ring. Okay. Sorry, I heard a ring on the Zoom chat. I don't know what that's something new. But essentially here, this can get very complex, right? Where you have the multiple authors here that share that book, or if you were to add it over here. So the way that it goes around it is by having that third table between both of these that makes the connection to all of these, right? And we'll see that work a little bit better with the SQL design. But up to this point, do I have any questions? I see, Francisco, that noise was someone logging in. I didn't know that was a thing. That's cool. All right. Well, let's see it with SQL draw. Actually, before
There's Roger. There's
I
a few questions.
thank you.
It's
Yes. What are your questions?
My question would be, what if there's an author with multiple books?
There's a what? I'm sorry.
What if there's an author, like one of the author IDs, they have multiple books that they authored in? Would you just add that in the author book table and have multiple book IDs in that column or in their
Correct.
row?
Yeah. Let's say Gary decided to expand his career and he made a second book talking about his journey through Platoon, right? So we would add that here. We would add a new book to the book table. All right. So 5, my journey in Platoon. All right. He really loved his time here. All right, so that's Gary. He made a second book. Let's make this shorter. All right. And now to make that relationship, what happens is he gets added to this table here where Gary now made a new book. So we have the connection between Gary and we have the connection between that book. All right. So we see here, Gary appears here twice, right? He's in here and he has he has 2 books, right? He has JavaScript and he has my journey in Platoon, right? So Gary has multiple books, and then we also see here that multiple books like JavaScript, right, has multiple authors, right? JavaScript appears here twice, and it has 2 authors.
Sweet, thank you.
No problem.
And I believe Gary and Haley had a question as well.
Gary.
Hello. So for the schema, I was just wondering, so all the IDs would just be primary keys and then like book and author would just be the varchar, right?
Varchar.
Varchar.
Yeah, so that was the purpose of the ID. So going back to talking about the data types, right? We talked about serial and primary keys, right? So the primary keys, we use those primary keys to reference our different data, right? Those primary keys were added within here, and we use those primary keys to create that relationship between the different tables. And it is an integer type in the schema. There is an option to add a primary key there, and we'll also talk about how it's going to be done in Postgres. But essentially, it is a number, yes, right? At its core, it's a number, and then it's incremented over time. That's where serial comes in. Serial allows you to increment that number every time you add something new to your tables. Does that make sense?
Yeah, it does. And then as like if you were to have like copies of each book, that would just be integer.
A copy of that book. Do you mean
Like in stores.
Oh, okay, yeah. We're gonna talk about that. Actually, I think it's next to talk about. Let's see. Okay, yeah. So let's actually go to that. Let me just ask a question here, Francisco. Or I can ask you guys. Do you guys take 10-minute breaks every hour on the hour still, or no?
It's more like
Yes, if you could. if you could hold 10-minute breaks, but I think at this point they would, I don't know at which point of the lecture you're at, but once you finish part one, they have a couple of assignments to complete. So there should be like an hour break before part two of the lecture.
Okay. I'm still in part one. We can go, or you guys can take a quick 10-minute breaks. What do you guys want?
Keep
I mean, I'm-
going.
Keep going.
All right, keep going. Let's go. All right, so we're gonna go ahead and we'll do a quick example here with GraphQL. I'm assuming you guys have seen this before when you guys went over Postgres. If not, you guys can go to GraphQL, and it allows you to create different tables, right? It'll even ask you what kind of database you're working with. So using the luggage, right, and the people. So we're gonna change the name of this table. This is gonna be person, right? This person has a person ID, and then you can change the different type of integers that it has, right? So we have big int, booleans, or different data types. We'll use big int for now. The difference between these data types is a small difference in storage, but also the lengths of how big these numbers can get, right? So if you're working for, let's say, the Texas Medicaid Health Department, and you are working with everybody in Texas, you might want to have a big int for your IDs, right? So we use big int as its data type, and then we have the options for nullable or not null. By leaving it like this, you leave it to be not nullable. The moment you click it, you see the question mark here. It gives us the option to be nullable, but it's supposed to be the ID, so we don't want it to be nullable, right? It should be mandatory to have it in there. And then you have the option to make something a primary key or a unique key or an index. So we'll keep that as the primary key, right? This person should have a name. And the data type for this is going to be, we're going to say bar chart. And then we're going to set it to, there's some people with some pretty long names. So we'll say 30. All right, so it's set it to 30. So bar chart 30, then we can expand it. There we go. You see it. And we'll keep it just like that for now. But if you want to see the other options carried, we can, right? We can have something like age. Age, we know that people don't really live past 80. It's not very common, so we can leave it as int. All right, so you can change that. Once again, you can make nullable or not nullable. And then for another thing to look at, we can do something like bio, right? We can have something about that person, and this could be a text field, right? If we know it's going to be like a long paragraph of who this person is. So you do have different options of different character types, and these are kind of the situations where you might use one or the other. If you wanted to use something like birth date, you can come in here, and there should be a date field, right? And then every single one of these, you have the option to make them nullable or not. But and you can also add constraints, something like age. Should not be less than 0 or more than, I don't think there's anybody higher than 110. I don't know who the oldest person is, but 110 or whatever you want to make it to. So you can add some kind of constraints there, right? That's where you would add the comment. Now, let's go ahead. We don't need all these extra columns. We'll keep it with person ID, name, and age, and then we can create a new table. And this table, we're going to call it passport. This is our passport table. This has a passport ID. And then what this is going to share is going to be a person ID. All right. And what's happening here is that essentially when we create a person and we create a passport, they share that one-to-one relationship, right? You see how, when we have one person that should only belong to one passport, and that one passport should only belong to one person, right? And that's how they're pretty much shared, right? All right, I thought it was 11:17. I don't know why I got confused the time. All right, so welcome back, guys. Today we're going to continue on with our lesson. The next part of today's lesson is creating tables utilizing SQL. All right, so how does Postgres and PSQL work? Well, essentially, Postgres and PSQL are not exactly the same thing, right? We're going to go ahead and talk about their differences. While they're closely related, they serve very different roles when working with databases. All right, so we're going to go ahead and break that down. What is PostgreSQL? Essentially, it's a very powerful and open source software called a relational database management system. We do have a hot mic. I think it's Owen. Appreciate it. All right, back to it. It's a relational database management system, or RDBMS for short. And you can think of it of like a highly organized storage space for all your data, right? You can store, retrieve, and organize your data here, similar to how a library stores books on different shelves, right? The role of Postgres is essentially just your database server, and it's what runs in the background to manage all your data, including handling the storage, updates, and the retrieval of it. All right. Essentially, PostgreSQL listens for connections from different applications. For example, your web applications can connect to it to store or retrieve the data, like keeping user profiles or saving different posts, right? But what is PSQL, right? Well, PSQL is a tool that is designed to help us communicate with our PostgreSQL database. And you can think of it as the interface or the terminal that lets us interact with that database, right? PSQL is the client or the communicator, right? It's what you use to send instructions to your PostgreSQL server. Now, the installation process of PSQL typically comes with PostgreSQL. So when you install Postgres, you also get PSQL as part of the package. Now, with PSQL, you get a command line interface where you can connect to the PostgreSQL server, write SQL commands, and manage your data directly. It's like typing instructions to your database and just watching it respond. And how do they work independently? PostgreSQL essentially just runs in the background as a server, ready to handle any incoming connections from different apps or tools, while PSQL is just one of the tools you can use to connect to PostgreSQL. Right, it doesn't store data itself. Instead, it connects you to Postgres server to execute the SQL commands. Right. Now, how do we actually connect to Postgres using PSQL? I'm assuming you guys already have an idea of how it works, but we're gonna go ahead and start from the top right. So we just discussed everything that comes in here. Now, actually connecting to Postgres, there's two ways that we can go about it. Well, actually one way, but we'll discuss how that one way works. And the way that it works is by using the PSQL command and the name of your database that you want to connect to. In this example, we have PSQL Postgres, which connects me to my Postgres database. Or I can do another one that I have, which is the one I use the most, PSQL Orthogonal 12. And it does the exact same thing. But what's actually happening under the hood, right? What's really happening is PSQL is running a series of different calls. The first one's going to be H for the host. And for this situation, we're using localhost, followed by the port that it wants to listen to. The port that it typically by default listens to is 5432. And then what it does, it grabs the user it wants to connect to, This user will be Postgres, and then the database that you want to connect to, which is also Postgres. Now that sounds a little redundant, like user Postgres, database Postgres. Well, what happens when you install Postgres, it comes with, I believe, a default or a template database already installed. And I don't even think you can delete it afterwards either. And that database is Postgres itself, right? So when we run this, it will prompt you with a password that you guys should have installed when you guys install Postgres. I enter that in, and we see that it did the exact same thing PSQL Postgres did earlier. The only difference is that I manually typed out everything that I wanted it to do. To quit out of there, /quit does the job. And then we can change this up again as well. We can say, change the user, and then let's change the database to Postgres so we don't have, it looking redundant and confusing. And it does the exact same thing. It asks my password for this user. And apparently I can't remember my password. Okay. Give me a second. Oh Lord. Okay, I'll figure that out later.
It's because you have numbers in your username.
I do, but that's not typically the issue. What is going on? Oh, my bad. Oh, you are right. I thought you meant the password. My apologies. Thank you, Gary. This is why you're class president. All right, so we run that. I add my password, and there we go. All right, cool. So that's how that works. Go ahead and quit. So this command here, the reason why we talk about it is because this is likely what you're going to use in order to enter servers living outside of your local machine. This is pretty convenient for us right now, but if you were to be working on a different server somewhere else, then it would look something like PSQL. You would have host, and then I'm not actually going to type anything crazy here. I'm just going to say something like remote host IP, right? And then you would add the port, and this will be like the port number that's listening to, and then the rest will be the same. Whether you have a different user on this remote location, you would do the same, right? Remote user, so on and so forth. All right, that's the reason why we talk about this way and how that works. Now, in summary, PostgreSQL is the database server itself, and PSQL is the tool that enables us to work with it. Now, if you want what we're going to talk about later easily accessible, you can use this cheat sheet here. I'm not going to open it because it's going to change what I'm working on. Actually, we can do it. All right. The cheat sheet that was created here, this is new, right? When I came through, we actually did not have this. It's one of the biggest things that we recommended as like improvements, to have cheat sheets to enable us to learn better. I know a lot of stuff that you guys learn, it feels like a lot of information. So take advantage of the cheat sheets. It pretty much talks to you about everything that we just did, and it breaks it down in what it's used for. All right, let's go ahead and go back to our tables. Now, turning the schema design into actual SQL tables. Now, can someone correct me if I'm wrong, but I'm assuming you guys already have some experience with Draw SQL, or no?
You said draw SQL?
Mm-hmm.
Yeah, we used it.
Okay. I know that was part of the assignment. I wasn't sure because I know I cut off early, so we couldn't go too much into it. But we're gonna go ahead and we're gonna create a quick schema that we can use for today's assignment. All right. And this schema is gonna be for a game table. So I'm gonna create a new table. I'm gonna go ahead and change the name to games. And this table needs to have an ID. So this will be my game ID. It's gonna be of type. Oh, what's going on here? It'll be of type int. The key is selected because it is a primary key. The next column is going to be our game title. And the type is going to be varchar. Now, I don't think any game is really called anything more than 50 characters, so we'll set this to 50. We're gonna add another column. This is gonna be our quantity column. We'll set this to int type. In this scenario, I am an indie game developer. I don't expect to make too many sales, so I won't have many of my games. So I'll just set it to int. And then I will add my last column, which will be price. In price, as we kind of went over earlier, we typically want to use decimals, right? Take into account cents. And for those of you that don't play games, most games come around usually around $60. Nowadays, you might see some $70. So I don't think we'll need anything bigger than 4. So we'll set this to 4. And then a decimal point of 2. All right, so decimal 4, 2. All right, and that's what our schema is going to look like. Awesome. So we have our schema done. Now, back to our VS Code. I'm currently within the lesson 5 RDBMS. Within the first lesson, schema design. Within here, you're going to find some different folders. You have example and data demo. I created myself so I can work through it during class. But within the data, you're going to find that we have 4 different CSVs. The one that we're going to be using for this specific demo is going to be the game.csv. All right, and when we open it, we see that we have our headers, which is game ID, game title, quantity, and price, which matches the schema that we created, as well as the actual data within it. Game ID is of int type. We have a bunch of numbers. The game title itself. The quantity, we don't see anything bigger than looks like 50, right? We can set constraints to this to see, to check that it's not greater or less than a certain amount, but that's a tomorrow lesson. And then we have the price. Notice that they're only 4 digits, decimal type. Nothing's greater than 59.99. So far, everything matches to what I want to use for my example. Now, and this is a pretty good example because this answers kind of like James' question, like how do you know how your schema should look like when you create your database? Well, in this scenario, imagine that you were contracted by some kind of family-owned game business. They want to resell games and whatnot. They give you a CSV file very similar to this, which essentially is just an Excel spreadsheet. That's what most people use these days. You grab that Excel spreadsheet, convert it to a CSV, you use that data. From that data, you create the schema that we just created, and then you can actually manage your database in that exact manner, right? So now that I have my CSV, I have my schema set up, I'm going to go ahead and actually create a SQL file for this. My SQL file currently is within my demo folder. Notice there is another store.sql file here. This is actually pretty much the answers to everything. We're not going to use it, obviously, but if you guys want to reference something, you can obviously come back and reference this. We're going to start from nothing, right? And the first command that we are going to use is going to be drop table if exist, right? Now, why do I do that? Drop table if exists. And then the table is going to be called games. All right, so whenever you guys are developing, you're probably going to be...
Excuse me, Roger.
Yes.
Can you zoom in like 2 clicks?
Yeah, of course. Could it go?
Yes.
Awesome. I don't think we actually need this, so let's go ahead and move this aside. So when you guys are creating your database, you're probably going to drop your database or not your database, your tables multiple times as you experiment with it. You add new columns, new fields, new data and stuff. And as you're running your SQL code multiple times, you might encounter some issues like you can't add this item in here because the game ID or the ID, whatever key you have, already exists. So we use drop table if it exists, so we can just drop it and then reinsert the information in there it makes it easier to develop our database, right? So a drop table if exists is kind of standard for the development process. So that's going to be the first table that we create. And what we should probably do here before I move on any further, I should probably create a database that I want to add my information in. All right, let's go to pSQL. And I can use \l, give me a list of all my databases. Notice I already have a storage DB already because I was working on it earlier, messing around with it. So I'll probably want to get rid of it. So to drop the database, I can do that while in Postgres or using the PSQL tool. So I'm in here, I can say drop database. And the database I'm going to drop is store_db, semicolon. And we see here, we get the response of drop database. And that removes it. When we go back, use \l, get a list of our database, we see that the store DB no longer exists. Right, so I removed everything that might have been in there. Let's go ahead and create that database again by using create database this time. And we'll call it store_db, semicolon, and we see create database. All right, go ahead and quit. I can also do that using the PSQL command, or actually not even using the PSQL command. I can use it through my terminal. Because Postgres is installed, it's kind of running in the background. I can use something like create DB and then do store DB. I can even do drop DB, store_db. And we notice it gave us no response. No response is a good response. I can check it again to show you guys, but we see here it's no longer present, right? Going back to my terminal, create DB. I'm gonna create that database again, right? No response is good response, right? So our database has been created. We now have something to dump our data into. All right, now that's done. Let's go ahead and continue from where we left off. We did drop table with exists, and the table is gonna be called games. Afterwards, the next command is going to be create table, and then the table that you want to create, which is going to be games, right? After that, you do open and close parentheses, add a semicolon at the very end, and then we can start working within these parentheses. Now in here, very similar to how we created our schema is where we're going to start adding our fields. The first field we had was game ID. We're going to make this type int, and it's going to be a primary key, right? Next will be our game title. And we established it's going to be varchar. We said 50 characters max. We're also going to say it's not no, right? There shouldn't be a game here with no name. So we're going to add the not no value in here. And then it should also probably be unique. Games don't repeat their titles, right? So comma. Next is going to be quantity. We established that to be an integer type, comma. And finally will be our price, which is of type decimal, length of 4 with a decimal placement of 2. And then I'm not going to add a comma here because that's the end of it, right? Make sure you guys have the semicolon here. The way that it's able to identify the start and beginning of new commands is by that semicolon. I know sometimes we get a bad habit of not doing it when working with Python. If you were a Java user, you're probably used to it, but SQL does not likes it if you don't use that semicolon. So make sure you use a semicolon.
Hey, Roger,
Yes.
don't you want to put the columns in quotes?
No, I'm sorry. What do you mean?
Oh, is it like that?
Yeah, like,
I
are you
thought you,
saying it like this?
yeah, I thought it had to go like, yeah. Is that right or?
No, not for SQL.
Okay,
We'll see how it works a bit, but no, you do not have to put it in quotes. That's a good question. Thank you.
gotcha.
All right. Now, how do we actually add this into our our database? Well, there is two ways that we can do it. The first one is going to be by using PSQL as our tool. After using PSQL, we're going to call the name of our database, which is StoreDB. And into StoreDB, I'm going to add the caret to let it know I want to put the following inside of StoreDB. And what do I want to put in here? I want to add store.sql, right? The reason why this is going to work is because I am currently within the working directory that SQL file is. And after I do that, we're going to see the next following commands. All right, we see, notice table games does not exist, skipping drop table. Right, so obviously there is no table there in my database. So it skipped that first command, right? If it exists, do it. If not, it's going to skip it. The next thing it told us was create table. Well, let's go ahead and check out our database to see what it looks like. We're going to use PSQL, and then I'll call StoreDB, semicolon. I'm now within my StoreDB, and I can check my tables by using \D. And we see here a list of relations. We have the games table. Well, to grab everything that's within this table, you're going to use the command select asterisk for all from games and then a colon, right? Select asterisk from games, semicolon, right? The asterisk means all. Make sure you guys add a semicolon here or it's going to get mad at you. We press enter and it returns to us an empty table with the names of our columns, game ID, game title, quantity, and price. Before I move forward, I have not stopped. Do you guys have any questions so far?
In that command, just a little further up in your terminal, it was PC equals store, yeah, less than store. So you're just putting it inside of that
Yes.
directory in a way.
Essentially that caret, that less than or greater than, it pretty much gives it like a direction, right? It's saying, hey, here's my database. It uses that arrow to point towards the database. I want you to dump into the database everything that's in the SQL file.
Got you. Okay.
All right. Awesome. So that's one way of doing it. Is there any other question before I move forward? Awesome. The next way, let's go ahead and exit out of here. Actually, I want to stay in there and I will show why. All right. I'm currently within here. I am in my database. The next thing will be using an absolute path, right? So I'm currently within my demo directory. My store.sql file is in here. What I'm going to do is I want to get the current working directory by using the pwd command, current working directory, right? And that's going to give me my exact path to where this directory is located at. I'm going to go ahead and copy that and then return back to the terminal that's running that database. And then here, I'm going to use a \I command. And what this command means, I believe it stands for insert. Don't quote me, I might be wrong, but I'm pretty sure it's insert. And then after that, I'm going to do Control V to paste that direct path. And at the end of the path, I'm going to do / and add the name of the file, store.sql, semicolon, and then I can run it. And we see here now that we get the exact same functionality, drop table, create table. Any questions about that method that we just discussed?
Do you always have to drop table and then create table, or is that just for instructional purposes?
That's for development purposes, right? Developing purposes, because as you'll see later, we have data already stored in our database. it might start getting conflicted with already existing data. Right now, it's okay because this example, the development process, you're going to be working with only a handful of data, maybe 10, 20 different things, probably max. There's no reason for me to add like an abundance of hundreds, 200 of different data when I don't really need to right now. I'm still just working with like the infrastructure of it. So by doing drop table, it exists. It removes any data that might be conflicting with it, and then it restarts from top, right? So it's for developing purposes. Now, someone might be wondering, well, why would we do one over the other if they both do the exact same thing? It doesn't really matter which one you do. It's honestly personal preference as far as I'm tracking. But they give you the exact same thing, right? One was able to do it using the exact path. The other one, because I was already within that working directory, might as well just do it in that manner. So either one would reach the exact same goal. Okay, moving on. So next, we have our schema. The database has been created. We now have our table within our database. Now it's actually time to add our CSV file data into this. All right. And the way that we're going to do that is by doing the following command. It's going to be /copy. All right. /copy. I want to copy games from, and then here I'm going to add the file path of where that CSV is located at. Right. It's currently within a different directory above from where I'm at right now. So I'm going to say /data. And then after that, I gotta get the CSV file. So I'm gonna say /game.csv. Right. And then I'm gonna do with CSV header. Right. That's gonna grab the headers I have in that CSV file and use that to format it into my my database. Well, let's go ahead and run that and see what it does. We see here drop table, create table, and copy 10, right? So it ran line 1, line 3, right? It dropped it, created, and then it copied everything from that CSV file. Let's go ahead and connect into that database, StoreDB, and I'm going to run the /d. Okay, I have a table here called games. Let's go ahead and query everything from games by using the select all from games, semicolon. And we get back all the data that was in the CSV now here inside our database, right? It's properly formatted using the headers, game ID, game title, quantity, and price. We see here game ID goes from 1 to 10, exactly how the CSV is formatted. Is there any questions about how line 10 works or what we just did?
How come for game ID you're using int instead of serial?
We are going to get to that literally right now.
Okay, thanks.
All right, no problem. So, the next thing is going to be adding something into our current database with already information in there, right? So we're going to go ahead and do, after line 10, we're going to do inserts. And I want to insert into, where do I want to insert into? I want to insert into games. What do I want to insert into games? Well, I want to insert the following: open and close parentheses. I'm going to insert game title, quantity, and price. Right? Game title, quantity, and price. Notice I don't have game ID here right now, and I'll explain why. Now, after I insert into games to where I want to enter it, I'm going to call the command values, and here's where we're going to add the actual values that are going to go into those fields. It's going to be Juan's game, right? He has 100 of his games, And he's a pretty humble guy, so he's only selling it for $10.99. Awesome. Let's go ahead and run that SQL file. And it's going to give us an error, right? It says no value in column game ID of relation games violates not null constraint. Failing row contains no, right? Then it says comma Juan's game, right? It's missing an item here, and that's the game ID. And this isn't really ideal, right? Obviously, I could do something like game ID, comma, and then pass in a deliberate ID here, which will be 11. But that's not ideal, right? Right now, it's easy because I got 10 of these. I can easily just add 11. But what if it's 1,000 in here? I would have to find what the last one is. And that's not really productive, right? It's counterproductive to how this works. So let's go ahead and change what this game ID is. And this is where serial comes into play. Instead of making it an int type, we're going to convert it into a serial. And let's go ahead and run that again. All right. So we see drop table, create table, it copied the 10, and then it did insert my game in here. Well, let's look at that data and see what it actually looks like. Store DB. I'm going to say select all from games. And oh, my bad. I should have removed this. We want to make it so I don't have to manually add a game ID, right? That's counterproductive. Let's go ahead and quit again, run it again. All right, there we go. I did it wrong the first time. We see here that even though I converted it into serial, when I try to insert on line 12 without adding the game ID, it's giving me an issue here. And it says game ID equal 1 already exists. Well, why is it saying that? I know that the CSV has game ID 10, so it should be 10, but it's trying to add this here on line 12 as game ID 1 when it shouldn't, because there's already a 10th one and we're using serial. Well, when we check our store DB, we see here Juan wasn't added. Well, let's check our tables. If we do \D, we see that there is now a new table added within the list of relations. Right? We have games underscore game ID sequence, right? Type sequence. Now, what is that? Let's select all from games. There we go. We select everything from that new games ID sequence table, and we get back last value log count, and is called. Well, what is that? Well, the last value is referring to the fact that the last value is how serial works, right? The game sequence is the table that keeps track on the incrementation of the serial type, right? It uses this table to reference the serial on your existing table to increment it every time you add something new. But currently, that last value is saved in as 1. So it can't add the next one because the last value isn't 10, it's still 1. We also see log count is called. We're not going to get too much into log count. Essentially, just know that the log count indicates the number of like cache hits left before the sequence requests new values from like the disk, right? It's a little bit too complex to talk about. Even I barely understand it. Don't worry too much about log count. But the is call table, what that's referencing is the incrementation of the table, right? The last value is equal to 1, but this needs to equal 10. Well, how do we do that? Well, there's a specific command that we use to manually increment this to the command that the value that it should be, right? And that command is as follows. We're going to call select. We're going to use the method set val, right? Set value, right? This method is going to manually change whatever this in the sequence table is showing. Now within here, what table do I want to change? It's going to be games underscore game underscore ID underscore SEK or SEQ, comma. And what do I want to do to that? I want to open and close parentheses, select whatever the max game ID is within here, right? That's going to grab the game IDs, which we know goes up to 10. It's going to grab the max value of all these, which is obviously going to be 10, right? And after that, I'm going to say from, and then the table that's from, and it should be games, right? The games table. So it's going to grab the max ID within the games table, right? It's going to set that as the value for the game ID, right? Now let's go ahead and see what that sequence table looks like before and after we change that value. So we're going to say select all from games game ID sequence, right? It's going to show us what it looks like before. We should probably move this right here before we change the value. And then we change it on line 14, and then we're going to call it again to see what it looks like.
You got a misspelling up there on 13 and 15.
Thank you. Much appreciated. Games underscore game. Okay. We also have to put freaking semicolon here because it's gonna yell at me. And let's go ahead and we're gonna create another one of these so we can see it incrementing even more. This is gonna be Gary's game. He isn't as successful. He only has 10 copies. And he is not as humble as Juan is. He's overpricing his game. So let's go ahead and run this SQL file again. And now let's look at what it returned. Well, from the top, it dropped a table. It creates the table games again. It copies all 10 of the items from the CSV. We call the game ID sequence again. Notice that the last value is currently set to 1. Right? On line 14, we change that value, and then we call the game ID sequence again. So here we set the value to 10. We call it again here, and we see that the last value has been updated. Right? It was 1, now it is 10. And then we were able to insert the next 2 lines, which is line 17 and 18 with our new games. Well, let's go ahead and look at our store DB. Select all from games. And we now see that Juan's game and Gary's game were successfully added in here, and the game ID was incremented exactly how it should. We can even check all from the games ID sequence table to see. Why do you not like that? From games, my bad. We see last value is now 12. Right? The value was updated. We had to do it manually, but now it's working as it should. Do I have any questions? My bad, I didn't mean to stop sharing. Yes, Juan, or who is it, James?
Yeah, I'm surprised when you select max game ID, you don't have to add 1, or I think I'm getting the process a little bit mixed up, how it's selecting the game ID and then it's adding for the next input.
That's a good question. Yes. So it's selecting the value, right? And it's setting it to whatever the max ID of game ID is from the games table, right? So this right here, this little function right here, it grabs whatever the max ID is from the games table, right? That's being set into this argument right here. This is what we're trying to update, the game ID sequence. And this method is what changes it. Does that make sense?
Yes, and then the next time you insert, it starts from that value, which is 10, so then it makes the next one 11.
Correct.
Great, thank you.
No problem. Because the serial, don't forget, the serial is still set here, right? So because it's set to serial, whenever we try to insert it, it grabs the last one, the last value we had, and it increases. The increasing of the number is being done by serial. Make sense? Quan.
Yeah, is that game ID sequence? Is that a separate table that it automatically created for you after you try to do the insert?
It created it when serial was added here on line 4. Right, the moment it creates a table and it has a serial type on it, it reads that, oh, okay, it's a serial table, right? That means I have to keep track of how the IDs work, and I have to manually increment it for him, right? So I'm gonna go ahead and create a different table that I can utilize to keep track of what the count is, right? So PostgreSQL will create that for you once it reads serial in there. Make sense?
Gotcha. So every single time for all these tables, we're gonna have to be referencing the ID sequence table to then get the ID sequence count right, and then go from there, right?
If you are importing a CSV file the way that we did, that already had like a bunch of data in there, then you would have to manually update that value. Yes. If not,
Okay.
then you don't know.
All right, thank you.
No problem. Owen.
Do you run into, is there any like bugs with serial when you start deleting different values, or not values, but data sets from data tables?
Not necessarily. No. The ID, the serial primary keys are all unique. So even if you were to delete the first item on that table, that item ID will never repeat. It will just keep incrementing. Does that make sense?
Yeah, thank you.
No problem. Tristan.
I'm not sure if I missed it or I'm just blanking out, but on line 14 where you have from games at the end of it, does it matter on your case sensitivity there?
So typically the naming conventions for your tables and even the fields, you want them to be lowercase. So my tables where I created, notice how it's called games all lowercase, right? So it will be sensitivity, yes. But if everything's lowercase, there shouldn't be a reason why you're calling a table uppercase. Does that make sense?
Yeah, sorry, I didn't word it right. I mean, the word you have in there from, how you have everything else capitalized, but then that word is lowercase.
That actually doesn't matter. Now usually it's good practice to do these commands like select from with as uppercase. You see it here, right where I select all from games ID sequence. If I change it to lowercase, it won't make a difference. It'll still work. But normally the convention for it, yes, you want to like get used to doing it all in capital letters. It'll still read
Okay.
it, but that's just kind of the convention of how it's done. Right? Kind of like how we do camel K's and snake K's and stuff like that.
Yeah, just differentiate. Okay.
No problem. Anybody else? Okay. Unfortunately, I still have like maybe like 15 minutes more of talking through things, but we are at our dead stop point. So we're gonna stop here, and then we'll take the extra 15 minutes afterwards to talk about it. I do apologize. This is the first time I'm teaching this class, so keeping track of the time with you guys, it's still a skill I have to learn. But we'll cover the last remaining material once we return from lunch. That way you guys can go and enjoy your time. If you guys have no questions for me, you guys are good for lunch. I believe the return time is 1:30. Let me check the calendar if you guys have something later.
Don't forget to stop the recording.
Yes, thank you. Stop sharing, and then I'm up. All right, welcome back, guys. I do have a meeting that starting like right now, so I don't have too much time. I just wanted to cover the last remaining piece of today's class. Shouldn't take more than 10 minutes. But just for the sake of the recording as well, and for you guys to cover it, we'll just talk through it real quick. The last thing I wanted to cover was altering the fields in your database. So let me just get kind of get my bearings real quick. We have PSQL store database. We have for games ID sequence. We can select all from games. And up to this point, we were able to add everything from our CSV file, as well as our additional entries for Juan's game and Gary's game. Now, what if we wanted to add a new column to what we already have existing in here? Well, the way that we will go about that will be by using the alter table command, right? Using the alter table, you pass in the table that you want to alter. In this case, we want to alter games. And then from the table, we want to add a column. All right, we want to either add or we can also alter a column. And what I'm going to alter real quick is going to be the quantities column. As you see here, we have quantity, but if we look at the data type, it's an integer type. All right. Now, real quickly, the SQL data types integer sizes are as follows, right? We have different types like small int, integer, and then we even have big int. What we use right now was integer, and these are the range of values. Now, int is actually pretty big on its own, right? It's over like 2 billion, right? Both negative and positive. We can go a little bit bigger than that. The difference between the sizes in memory, we see that here, 2 bytes for small int, 4 for integer, 8 for big int. Let's say for whatever reason, Gary's game just blew up, right? They really loved it. They didn't care how pricey it was. They full sent it. So we're gonna go ahead and change that column. So we're gonna say alter column, and I'm gonna want to alter the quantity column. And the way we're gonna do this, we're gonna do set data type big int. Right. So let's go ahead and exit out from here. We're gonna go to PSQL store DB, and I want to add my store.sql. All right, we see here the alter table. Let's go back to our store DB. Select all from games. It's still in here. We don't see it directly here. I believe we do.
Did you forget the? You didn't add it a semicolon at the end of your line 2021. You just directly copied it.
I did not. You are absolutely right. For some reason, it didn't give me an error. I'm gonna go ahead and assume that it didn't give me the error because it was probably the last item in the field. Now, what we want to do, we can probably do a command like /D. I think we can do page type of. Page type of. Now, I'm not sure if this is correct. Did not find a relationship between type of. Okay, I guess I couldn't see it, but right now, as it stands, that quantity field is now a big integer. Now, the issue when altering columns doesn't really come from altering from int to big int. The issue will come from going from big int to integer, right? And the reason for that is because we can always scale up. But if there's data that exceeds the size of whatever this is, right, for whatever reason, maybe the quantity of something is like 3 billion, and we try to bring it down to an integer where obviously the range for the int doesn't go as high, it's going to give us an error. And I don't have that on here, but just know that type converting in this matter can be disastrous if the data in your database does not match, right? So just keep that in mind when altering. We can always go up, but we can't come back down, right? So it's good to start from small to big. So we alter a column. Let's go ahead and add a column real quick. So add column. And I'm going to add a column that's going to be, let's say, it's fun, right? We want to rate the games if they're fun or not. And we're going to make this a Boolean field. So we'll say add column is fun, Boolean. And notice if we try to do it just like this, we might get an issue. And that's because, oh, okay. It just does what it wants. All right, let's see what it did for us. Store db, select all from games. It's fun, but notice here, there's nothing in here, right? So we got it in there, but because we already had data in here, the data is pretty much empty. So what we can do as well is give it a default. So we can say default, and the default is going to be true. Once again, run the code, go into the database, select all from store db, I'm sorry, from games. And now we have if fun is equal to true. Now, let's say this isn't really relevant to my application. I don't really need to know if it's fun. I can also drop a column. I'm going to drop it's fun. Let's stop this. Column is fun. What are we talking about? It's in there. Did I misspell something?
I think it's because you initialized it again, but you didn't actually add it this time. It's trying to get rid of something that doesn't exist.
Hmm. Let's see. Select all from games. Well, it's not in there. I see. Okay. Thank you for that. It dropped it. It's no longer in there. Good to go. And that's kind of how you alter your tables, the columns. You have some other examples here of different data types. The reason why I went over it because it could be a little confusing, especially when you see stuff like the constraint, or even something like I think when I used I think it was this, it was giving me errors, or was it this? So I just wanted to go through there and show you how it's done in real time. And real quick before I finish off here and head out to the meeting, more about PostgreSQL. Another way to connect the database is using, I believe it's what's called URI. This is actually very new to me because I did not have Flask when I came in. You guys probably have some experience with this working with Flask. So using a URI to access PSQL. Right, so essentially, here's the template for it. What you will do is replace your username and password with the username that you guys are trying to use. So for me, I'm not gonna type out the whole thing because my password, I use it for everything. Not probably the smartest idea, but I'm very forgetful. But it would say something like the username I want to use will be Arthur Lagarde 12, and then my password would be whatever, followed by the local host. You give it the host, and then the database you're trying to connect to, stored DB. and then you would run this. Oh, give me issues. All right, you would run it. Like that, right? So you have PSQL, you have the entire URI. It will work if you don't use the quotation marks. Just be aware of that. And another thing that I want to bring up is going to be the password, right? So because it's a URI, it works as a URL. There's certain things that it won't take. And if you have special characters in here in your password, if you're using like exclamation marks or whatever dollar signs by trying to make your password more complicated, it's gonna have an issue with that, and it's gonna say that it's wrong. And now to get around that, you would have to replace it using the encoding for that, right? For my password, I have special characters like an exclamation mark. So instead of the place of the exclamation mark, I would have to replace it with the %21, right? So if you're trying to use that to access your database and it's not working, more than likely it's probably because it does not accept your special characters. Do I have any questions before I drop from the call? Yes, James.
Why do you have to do the alter table things like drop, add column, alter column instead of just editing the table that you have set up at the top of the page?
That's a good
instead?
question. So right now I'm still developing, right? I have like my skeleton, I'm working on it and whatnot. The alter table really comes into play whenever you have an established database and you're trying to make some changes to it, update it, right? Fix the scalability. You're not going to drop the entire database and restart it, right? You might have like thousands upon thousands of different data types in there. You don't want to mess with any of that. Not a smart idea. So you would want to go there and then maybe alter a column or add a column. Now, granted, you want to do that sparingly unless it's really needed to. But we use that command instead of having to go through every single individual type and altering every single one, right? That's when it comes in handy. Make sense? Awesome. Anybody else? All right. If I have no more questions, thank you guys for today. And I will be seeing you guys at 4. I believe we have an algorithm today. So I'll see you guys then. I'll open up the breakout rooms. Gary, please stay back so I can hand you host. Thank you all.
I will be in TA room 3 for any questions, comments, or concerns as you guys quest on.